We use the DFM Concurrent Costing software to analyze individual parts to come up with an estimate of what the cost of manufacture of that part should be. I'm going to work through an example here to show you how the software works kind of at a high level. And you can look to the tutorials in the software manual, which you can download from our website, dfma.com, or you can look at some of the sample files for some more information on the details of the specific manufacturing processes. There are essentially three areas of the screen that we work with. The process chart here on the left-hand side, the questions panel on the right-hand side, and the results box in the lower left-hand corner. The results box is where we see the bottom line costs of the things that we're looking at. And we're calculating a piece part cost, which is the sum of material, setup, process, and rejects above it. Should the process warrant, we'll calculate a tooling investment, and we'll amortize that tooling investment over this life volume number to arrive at a tooling cost per part. The total cost line item that you see here is the piece part cost plus the amortized tooling cost. So depending on whether you want to include or not include the amortized tooling cost in the cost of the part, you can look to the piece part cost or the total cost and the tooling investment as the numbers to reference. So I'm going to put in here the name of the part, so I'll just call this sample analysis, and I'll put in here a life volume of 250,000 pieces. Now that value could obviously vary widely depending on the process, depending on who I am and what parts I'm making for what markets. I select an envelope shape which influences the guess the software makes about what the geometry parameters of the part are going to be. Now the software takes as input a description of the part geometry, and it's in the background calculating cycle time. That cycle time is then filtered through our machine library to arrive at process costs, and the geometry pieces for the volume and the weight and the projected area are used in conjunction with other values that exist in, for example, our material library to arrive at some of the other pieces, one of them being material cost. So if I just put in some basic dimensions here of a box, let's say it's 2.5 inches with a 187 wall thickness, it's 4.75 inches wide, and it's 6.875 inches long. And then I select a process and a material. The software will load for me the material database. Now, what I'm presented with is a list on the left-hand side of the manufacturing processes that we have cost models for. There are 30-something of them in here. It is not editable directly by the user. I could use our user process library, in which case I would see user process here as a line item, and then I could create my own primary manufacturing process cost models in our user process library. That's a topic for another tutorial. But on the right-hand side, I have the list of material categories that exist by default in the material library. That is completely user customizable, and you could reference the how to add a material to the material library tutorial if you wanted to see some information on how to go about doing that. So at this level, if I know I want to die cast this shape, I'll pick cold chamber die casting. And on the right-hand side, the list of materials turns red and green to indicate to me which materials can and can't be used with the cold chamber die casting process. So I'm going to open up aluminum, and I'll pick the A356 cast aluminum. And you see when I do that, the same thing happens to the manufacturing process list on the left-hand side. They turn red, green, and yellow to indicate to me whether or not those processes are compatible with that material. Now yellow is an indication to me that I could do that, but it's violating some principal limitation that we've set in the software, which is also through the material library editable by the user. So if I were to select automatic sand casting here and say OK, you can see the software warns me that section thicknesses of less than 0.19 inches are likely to be impractical. Do I want to ignore this limitation and proceed? I could say yes, and it would calculate the cost for me. Or I can say no, and I can come back and pick two things that are green. In this case, I'm going to pick cold chamber die casting, the A356 aluminum, and I'll say OK. The software then takes a guess based on the envelope shape that we specified and the envelope dimensions that we entered about what this part looks like. Its volume, its projected area, its outer perimeter, the number of surfaces. It pulls from the material library the costs of the material, the scrap value. It sets by default a batch size to, in fact, 1/8 of the life volume. And based on these inputs, the software has selected a 400-ton cold chamber die casting machine as the least expensive machine that exists in our machine library that's capable of making this piece. And based on the cost structure that's stored in the library for that machine, the software has calculated this piece part cost of $2.67. And I can see the distribution of cost up above that, the contributions of materials, setup, process, and rejects to that total piece part cost. We've also calculated a tooling investment, $96,885 here, and we'll note that is for a 2-cavity die in this case. The software has an algorithm built into it that will automatically select the optimum number of cavities based on the production volume, the part size, and the part complexity, which influences the tooling cost calculations. Now I can change anything I want to change here. So if I change the batch size to be 15,000 and I change the material cost to be $1.15 with a scrap value of actually just 5 cents, I can click calculate, and everything that's in this column shifts over to previous, and then we recalculate. So we can see now, based on those changes, that I've gone from a piece part cost of $2.76 to a piece part cost of $3.50 as a result of those changes. Now the fields turn blue to indicate to me that I have edited that value. It's not any longer a default value or a calculated value that was placed by the software. If I want to go back to what the default material scrap value was, I can simply right-click on that field. I can pick Unlock. It'll remove the blue highlight, and if I click Calculate, we can see it'll replace that value with the library value for the material scrap value. And accordingly, my piece part costs have changed as a result of that value for the scrap that I'm now going to get. I can click on the machine level to review or change, if I want, the machine rates and operator rates. I can right-click on the machine and pick Change Machine, in which case I could select a different size machine from the machine library. The yellow ones are too small. The green ones are okay, or machines that will work. I'm going to leave the default selection alone here for now. And then if I want, I can click on the die casting operation line item, and I can see the breakdown of the cycle time. So 31.5 seconds is our calculated cycle time for casting this part, and that breaks down according to this distribution of cost. And then finally, the $92,500 that we're seeing here for the cost of the die is coming from these costs. So much for the die set, the custom work, and then so many hours at a die manufacturing rate to machine the cavity and core sets. Now once I've gone through and I've selected all of the appropriate values and clicked Calculate, I would have at that point a representative piece part cost. If I want to, I can right-click on the tree. I can select Insert Operation, and from the list of operations that appears, I can add secondary operations to roll up the cost of things I do after I've made the part by a primary shape forming process. I could, under Inspection here, add Inspect Visually. I'll pop that on the tree, and you see I get a list of inputs now that I have to verify are correct or edit to be values that I want to change them to. If I click Calculate, I'll get a cost here at the lower level for that visual inspection operation. So wherever I happen to be on the tree, these cost results down in the lower left-hand corner show me the costs for that level or the sum of the levels below it. So if I click on the die casting process line item here, that's the cost of the die casting. If I click up at the top, that $3.38 now is the piece part cost inclusive of that Inspect Visually operation that I added. With a process like die casting, I could also insert some secondary machining operations. I would do that first by inserting a machine tool setup. Maybe we'll put it on a CNC drilling center. And then once the drilling center has been added to the tree from the machine library, I can insert my machining operations. So maybe I have to drill a couple of holes in this part. So I'll pick drill multiple holes, and here I would specify the dimensions of the feature. So I might want to drill a hole that is 201 in diameter, 187 thick, and maybe there's 4 of them that are machined in this piece. If I click Calculate, you'll see I'll get a cost now. First of all, a time, and then a resulting cost for the drilling operation. The setup, load, and unload line item, I'll put this part into a vertical fixture, and it doesn't need to be reversed in the fixture. I can get away with one clamping of the machine tool. So if I click Calculate now, I can see the cycle time estimate here for the secondary machining and the resulting cost. I can see the cost for the die casting operation, and then again, all the way up at the top here now, $3.96 represents the cost of die casting this piece, drilling the holes in it, and then doing the visual inspection at the end. So this has been a real brief overview of the sort of real fundamentals of how this software works. Regardless of process, it would be the same. I'd enter the envelope dimensions of the part, I'd select the process and a material, and then I go through and I refine all of the inputs that are selected for me by default to arrive at a better estimate of the total. Then I can use the reporting facilities in the DFM software to export the data or print these reports, to share the data with members of my team, my outside suppliers, my supply chain management group, whoever it is that I want to communicate the cost information that I've developed as a result of the DFM analysis with.